Okay, our next pattern is called the visitor pattern. And the visitor pattern allows you to add one or more methods to a hierarchy of classes without changing the hierarchy. Now, the decorator pattern had a similar intent, to add functionality to a class without changing it. The reason why this is important is there are times when we cannot change an existing class. So perhaps we're using a class that we're not in control of. Maybe we bought it from some company. But we'd still like to alter it. Or perhaps we've released a class and many different organizations have become dependent on the interface, and changing the interface would break many different applications. So imagine, for example, if somebody changed the name of the Java object toString method to something like print. Okay, so we get rid of toString and we change it to print. That simple change to the interface would break billions of lines of Java code that's already out there. So once an interface is released, it becomes very hard to change after that release point. The visitor pattern allows you to add functionality to a class without altering its interface. Okay, so the intent of visitor is to represent an operation to be performed on the elements of an object structure. Visitor lets one define a new operation without changing the classes in the hierarchy. Okay, so let me try and motivate this a little. Imagine we're creating a hierarchy of modem objects. So a modem is what we used to use to connect to the internet. Okay, so there's this general modem class, and then a derived class for each modem manufacturer. So there was this company called Hayes, one called Zoom, and one called 3Com. They all made modems. However, each modem might be used on different platforms, okay, different operating systems. So the Windows operating system, the Linux, the Mac, and of course each one of those operating systems has many different variations and versions. So there could potentially be a lot of different types of configuration that we might want to do on these modems. Okay, so in each platform, in each operating system, the modem needs to be configured to work with the operating system. One might be tempted to add a separate method called configure or something like that to the class, one for each operating system. Okay. So now we're going to change the modem class where we'll have configure Windows and configure Mac and configure Linux. And we potentially could have many of these because there are different versions of Windows and Mac and Linux. Okay, so there's a new method for each operating system that we have to support. But now every time a new platform comes along, we would need to make changes to the entire hierarchy of classes, okay, in the modem hierarchy. This can become a maintenance nightmare. So instead what we're going to do is we're going to introduce the visitor pattern with this thing that we call dual dispatch. And dual dispatch just means that we're going to have two polymorphic calls happen in quick succession, simply to select the correct behavior that we want to have happen. Okay, so let me show you the application of the visitor pattern. Okay, so over here we have our modem interface, right? And we're going to add one method called accept, which is going to take this thing called a modem visitor. And then we have our normal, or the same subclasses that we had before, Hayes, Zoom, and 3Com. But now we have this interface called modem visitor. And we're going to add one method for each type in the hierarchy. And the method is going to be called visit. So we have visit that takes a Hayes modem, visit that takes a Zoom modem, and visit that takes a 3Com modem. Okay, and then we're going to create one class for each method to add to the modem hierarchy. So we wanted to have a Windows configuration method that we really wanted to add here. Instead of adding that one method, we're going to create a subclass of the visitor. Then we have a method to configure a Mac. Well, we're going to inherit from the modem visitor and have a Mac configuration class. And similarly with a Linux configuration. Okay, the visitor classes really represent a method that we want to add to the hierarchy. That's what the visitor pattern is all about, is adding methods through or by creating these subclasses. There is a derived visitor for each modem type, and the visit method in those classes really represent a method to add to the hierarchy. Okay, so the way this works is in this accept method that comes in the modems. Okay, we're going to pass in a specific modem visitor, in this case for the platform, one for Windows, Mac, or Linux. Right, those are our visitors, to basically specify the operation that we want to have happen. We want a Windows configuration or a Mac configuration. Okay, so we pass in a visitor, a concrete visitor. The second step is we're going to have the modem call visit on the visitor and pass a reference to itself as a parameter. So remember, the visitor, there's a visit method for each one of the classes that we're basically extending or adding functionality to. And in this particular case, if this accept belongs to the Hayes modem class, when we say v.visit and we pass in this, well, this is a Hayes modem. And what's going to happen at that point is the flow of control is going to go and select off this visit method. Okay, and if we were talking about a Windows configuration, that would be how we do a Windows configuration of a Hayes modem. Okay, so the dual dispatch was we called accept on one of these modem classes, and then we called visit right after, and we passed a reference to the modem, and that kind of selected off the correct visit to call. Okay, the modem and the operating system specific configuration will be called because we pass in a visitor to a specific modem type, and then each modem always calls visit and passes a reference to itself. Okay, then the correct method is going to be called based on the type of object passed in. So let me show you a sequence diagram. Okay. This is just the generic interaction between a generic modem and a generic modem visitor. So somebody calls accept on one of the modem types, and we pass in this modem visitor called v, and then we say v.visit, and we pass a reference to ourselves, or this would be the modem doing that. And again, based on the type, we're going to go and select one of V's. So this is V here. V is a modem visitor. We're going to go in and select the correct visit to call, and that's going to produce a specific modem and operating system configuration. Okay. Now let's look at let's mix and match these a little bit. It's another really good nice thing about the visitor pattern. It allows you to mix and match different combinations of additional functionality. So let's say this time we have a Hayes modem. Okay, so Hayes inherits from the modem, and we call accept, and we pass in, let's say, a Linux configuration modem visitor. Okay, so again, in this case, the thing that gets passed in, V, is really one of these guys here. So the Linux configuration is a modem visitor. When we say v.visit and pass in this, because we know what this is, it's a Hayes modem, that's going to go to the Linux configuration class and call visit that takes, the Hayes. So we'll know that it's a Linux operating system and a Hayes modem by the combination of this dual dispatch. Okay. Let's look at a couple other basically similar things we could do here. Now we have a Zoom modem. It's a different type of modem, but it is a modem. And a Mac configuration, that's a different type of visitor. So we're going to call accept and pass in a modem visitor. In this case, it's a Mac configuration. And we're going to say v.visit and pass in a reference to ourselves. In this case, it's a Zoom. And that's how we're going to select the Zoom and the Mac configuration. And then just one last one here. Now we have a 3COM modem, a Windows configuration. We pass in a visitor. We say v.visit, pass a reference to ourselves. Okay, and that's how we're going to get a 3COM Windows configuration. Now all of this works because of method overloading. Method overloading is when we have two methods with the same name but different signatures. And a signature is really just kind of like a parameter list. Okay, so if we had in some class, if we had the method foo, we could have multiple instances of foo as long as they have different signatures, as long as they accept different parameters, either the number of parameters or the types of parameters. So here's a foo that takes a string, here's a foo that takes an integer, and here's a foo that takes a double. Okay, when the flow of control reaches this point, we're going to call the foo that takes a string, and here we're going to call the foo that takes an int. Okay. The compiler looks at the type of the argument, okay, the type that's in the parentheses here, and chooses the most appropriate overloaded method. Okay, so now adding a new operating system is pretty easy. We would just create a new subclass of the visitor and add a new visit method. The modem class, and in fact the whole modem hierarchy, doesn't need to change when we add a new operating system. Okay, so let's take a quick look at the structure here. The basic structure of a visitor is like this. We have some element with an accept, and then we have a concrete element. These would be our modems. And then we have a visitor, which has different visit methods, one for each concrete element. And then we have a subclass that basically represents an operation. Each one of these classes is an operation that we want to apply to the classes over here. Okay, so the participants here, we have the visitor that declares a visit operation for each visited class in the hierarchy, okay, or the concrete element. And then the concrete visitor that implements visit for each concrete element. And if you don't remember nothing else from the visitor pattern, remember this. This class really just represents a method that we want to add to the hierarchy, but for some reason we can't. Okay, either we don't have access to the code or we don't want to break the interface. That's all the visitor pattern is. It's a way to add methods to a hierarchy. Then we have the element class that declares an accept operation, and then the concrete element that implements accept and passes a reference to itself to the visitor. Okay, so visitor is often used with the composite pattern. So let's recall the composite pattern here. This is for storing hierarchies of objects. So we have this client that knows about a generic component, and the component will either be a leaf or a composite. And so we have this type of relationship here. Okay, these guys are leaves. Okay, they have no children. And these guys are composites because they're composed of, well, this guy's composed of one leaf and another composite. The composite has a list of children whose type is the generic component. So the children, so this one's child, for example, we had one composite and one leaf. But that's okay because a leaf and a composite, they are components. So the children is a list of components. And when you call some operation on composite, you're just going to march through the children and call operation on each one of those. If it's a leaf, it'll do leaf behavior. If it's a sub composite, it will do the exact same thing, march through its children and call the operation on it. Okay, so visitor works great when we want to visit all the objects in a hierarchy, like we often see with composite. Okay, so the example I'm going to show today says, imagine we have a hierarchy to track parts. So whatever, these are widgets, where a widget could be either a piece part or an assembly, where a piece part is just an individual part that can't be broken down anymore. An assembly is a collection of either more piece parts or further assemblies. Okay, so notice here, this might be a widget. It has one piece part and an assembly, and this assembly has several piece parts and a sub-assembly, and eventually all the assemblies are made up of these piece parts, but they might come in different packages, for example. Okay, So if we were going to implement composite, we would have a generic part class with add and remove that are part of the interface, and then the operation, we'll just say set the part name is the only operation. So we have a piece part, that's the leaf, and the assembly, which is really just a collection of other parts. Maybe piece parts, maybe other assemblies. Okay, so imagine this code came from an outside company that happened to support the visitor pattern. We would then have the ability to add functionality to the hierarchy without changing the part hierarchy. So when visiting, the visitor can maybe, I don't know, print only the piece parts. So if we're going to print out some receipt or something like that, maybe we only want to see the piece parts that come in a total assembly. Or maybe we want to count the number of piece parts and count the number of assemblies. So these are two additional pieces of behavior that we want to add to the hierarchy, but we don't want to change the part, the piece part, or the assembly. So with the visitor pattern, we can do this without adding those methods to the part hierarchy. Okay, let's see how. So here we're basically combining the visitor and the composite pattern. So over here in the part class, I'm adding this accept method, which is going to take a part visitor. We still have our piece part and our assembly, which holds other parts. Now the part visitor, there's a visit method for each one of the types that we want to add some behavior to. So in this case, there's only two subtypes, piece part and assembly. So there's a visit for each one of those. Now if you want to add some behavior, some function to these classes, what you would do is you would extend or implement the part visitor interface, and you'd put the behavior inside this class. So what this means is this class now knows how to deal with a piece part and an assembly. Okay, and what this is going to do is going to basically print only the piece parts. And the part count visitor, this is going to, again, it has two visit methods. It's going to increase a counter for piece parts, and then it's going to increase a separate counter for assemblies. Okay, so this kind of the structure is to me looks very familiar, because I know this is what the visitor looks like. Okay, so let's look at some code. Let's start with the part class. Okay, so I'm going to make the part class abstract because I want to store the part name. Whether you're a piece part or an assembly, you have a part name. So I'm going to push that up in the hierarchy. It's abstract though because of the print. So how do you print? Well, it really depends on what type of part you are, if you're a piece part or assembly. And similarly, accept is going to implement each subclass is going to implement accept. Okay, so this abstract class, of course, can still have a piece of data. We just can't create instances of part. And we have a part constructor that will just call the setter to set the part name. Okay, then we have add and remove. These are typical composite pattern methods, which we just throw an exception so the derived classes can accept this behavior and only override it. The assembly, in fact, will override these. Okay, then we have just getters and setters for the part name. Okay, now let's look at the piece part. This is the leaf. So piece part extends part. It calls the base class constructor. It overrides print to do something piece part specific. Okay, and it has this accept method. So here we're going to say the part visitor, PV, dot visit, and we're going to pass in a reference to this. And this, of course, because we're in the piece part class, will always be a piece part object. And that's going to make sure that we call the right visit method on that visitor. Then we have the assembly. This is also a part. So here we have a list of parts called parts. We call the base class constructor. This accept is a little more, slightly more complicated. So yes, we're going to say we get passed in a visitor, and we're going to say visit this, but then we also have the children to worry about. In this case, we call them the parts. So we're going to call accept on each one of the children and pass in the part visitor as well. Okay, and then we have our add and remove, and finally an overridden print. Okay, so this accept method is a way to add behavior to the assembly and piece part classes. Okay, now it's just up to us to create our own visitors. So let's start by looking at the part visitor interface. Okay, again, we just have a method called visit for each one of the classes that we want to add behavior to. And let's look at maybe the part count visitor. Okay, so this is a visitor that's going to go in every single object in that hierarchy, whether it's an assembly or a piece part. We're going to be able to have this visitor go and basically visit each one of the objects in the hierarchy. That's why it's called the visitor pattern. And this visitor has a couple of counters to keep track of the number of assemblies and the number of piece parts. So when you call visit on this visitor, of course, we know whether it's an assembly or a piece part that made the call to visit in the dual dispatch. So here we're just basically increasing the number of assemblies if this visit gets called, and if this visit gets called, we increase the number of piece parts. And we just have some getters and setters. And what we'll see in a second is the driver will ask the part count visitor for how many piece parts were there and how many assemblies. Okay, we also have this, let's call it a piece part print visitor. Okay, so what this one was going to do is only print information about the piece parts. So again, if we were doing some kind of receipt or something for this complicated assembly, we might only want to see, well, what are the actual leaf components or the actual piece parts? Well, in this case, if we ever get passed in an assembly, we won't do anything. But if we get passed in a piece part, we'll print out, I don't know, let's say the part name. Okay. And the last class we'll look at is the driver, okay, which kind of brings it all together. Okay, so we have this list of parts. Remember, part can be an assembly or a piece part. Starts out empty, and then we add a couple parts. So I have this method create part 1, which basically just creates an assembly, adds a bunch of piece parts, creates a sub-assembly, adds a couple sub-piece parts to it. Okay, so it's a fairly complicated assembly. And then I have another method called create part 2, which does something very similar, but it's just a different configuration of assemblies and piece parts. Okay, so we have two fairly complicated assemblies that we're adding to this list called order. Then I create just a plain old piece part. I call it part 3, and I add that to the order. So the order now has the two complex assemblies and just a simple piece part. Now what I do is I'd create a visitor. Okay, this is a part count visitor, and what I want to do is go through each part in the order. And for each part, I'm going to call accept, and I'm going to pass in the visitor. And of course, what's going to happen, this is a part count visitor. So each object in that hierarchy, whether it's an assembly or a piece part, is going to be called, or we're going to call the visit method on each one of those objects, and those objects will basically call, we'll call accept, and we'll pass in the visitor, and then the part will call visit and basically pass a reference to itself to make sure the correct visit method is called. And this should sum up all the parts. Okay, so we can, in the driver here, we can say the number of assemblies in the order is, we can just use the visitor and call the get number of assemblies, and the number of piece parts, again using the same visitor, we could call get number of piece parts. Okay, remember it was the visitor that was keeping track of those counters. And then similarly, if we wanted to print out only the piece parts, we can have this piece part print visitor, where we're going to go through again all the parts in the order, call accept, and pass in the visitor for all the different parts, and only the piece parts will actually get printed. The assemblies we won't do anything. Okay, so just to review, the visitor pattern is really just a way to add a method to a set of classes in a hierarchy where you can't change that hierarchy. Okay, you have to do it from the outside. And visitor is just a way to get into that hierarchy from the outside.